You know how you can order a package from an app in one country and, instantly track it from another? Or how a streaming service just works perfectly, whether you're in Tokyo or Toronto? Well, today we're going to pull back the curtain and look at the actual blueprint for the global apps that make all of that possible. It really all boils down to that one question, right? How in the world do you serve millions of people across different continents all at the same time? The answer isn't some single piece of magic tech. It's a whole journey deep inside the modern cloud stack. So let's get into it. So the first major hurdle is just sheer scale. And honestly, the best way to think about it is this. You're not just building a website, you're building a global chain of retail stores. You absolutely need a storefront in every major city to serve your customers quickly and reliably. Now, in the digital world, that means we're chasing three big goals. First, high availability. You got to make sure the app is always online. Second, low latency, which just means it's got to be lightning fast for everyone, no matter where they are. And finally, resilience. So if one part breaks, the whole thing doesn't come crashing down. To pull this off, companies spread their digital storefronts across multiple cloud providers. Think AWS, GCP, Tencent Cloud, you name it. But this isn't just one product. It's more like a complex symphony of technologies, all working in concert. You've got Kubernetes managing the applications in each region. You have global load balancers, or GSLBs, that act as the traffic cops, sending you to the closest location. Secure networks like VPNs connect the whole shebang. And data is constantly being copied, so an order you place in Tokyo is instantly visible in New York. Okay, so a user's request has been sent to the closest data center. Now what? Well, it needs to get inside the front door. And for years, that front door had a very specific name. But as things got way more complex, it was definitely time for a major upgrade. That original door was called Kubernetes Ingress. It was the standard way to handle all incoming web traffic. And it basically acted like a simple bouncer at a club. Just checking IDs and pointing people to the right room. It was simple, and for a while, it was effective. But as the party got bigger and way more complicated, that simple bouncer just couldn't keep up. Ingress started mixing up the jobs of the building manager and the event planner. It only really understood one language, HTTP. And for anything fancy, you had to rely on these vendor-specific secret handshakes. It just created a ton of confusion and a lot of technical debt. So, recognizing these problems, the Kubernetes community basically made a clear announcement. It was time for a successor. And this wasn't just some patch. It was a fundamental rethinking of how traffic management should work, right from the ground up. You see, the real genius of the Gateway API is that it's designed around roles. It cleanly separates who is responsible for what. The infrastructure team can build the front door, the platform operators can manage the locks and keys, and the developers can just focus on defining where their app's traffic needs to go. This gets rid of all that confusion and lets teams work independently. Plus, it speaks multiple languages, multiple protocols, and has all this advanced routing built right in, which makes it incredibly portable and powerful. Okay, so our request is now inside this new sophisticated front door. But hey, before it gets to the main event, it has to pass through a security checkpoint. And this is where we hit a critical trade-off that pretty much every architect has to think about. And here we can see that trade-off in action. The top API gateways, they're all really good at enforcing security policies. But if you look under the hood, there's this constant tension. Do you pick a gateway that gives you comprehensive protection right out of the box? Or do you go with one that's all about raw speed, even if it means you have to do more work to handle specific threats? This table shows us exactly why. See, all three gateways can handle an expired JWT. That's just a digital token for authentication. But then look at things like replay attacks or schema validation. A gateway like AWS is blazing fast, but you've got to do some extra configuration to block those specific threats. On the other hand, solutions like APG and Kong handle them more natively, but that might add a few milliseconds of latency. It's this constant balancing act between speed and built-in security. So at this point, we've got dozens of clusters, multiple gateways, and all these complex security rules. How do you possibly manage all of this without it just becoming total chaos? Well, you need a central headquarters, a place to define the strategy for all of your global stores. A formal reference architecture is how you do it. It organizes all this complexity into 5 logical planes. Just think of it as the master blueprint for your entire global operation. It separates the physical foundation from the central brain, from the user interface into these distinct, manageable layers. Let's just quickly look at how the most important ones work together. First up is the infrastructure plane. This is your foundation.
It makes sure every single store or cluster is built from the exact same approved standardized blueprint. So whether it's in Europe or Asia, it has the same secure and reliable base, no exceptions.
Sitting right on top of that foundation is the platform control plane. This is the central headquarters. This is the brain of the entire operation. It's where you set all the rules, all the policies, and all the access controls for the whole fleet, making sure every single location follows the exact same operational playbook. And finally, you have the service and presentation planes, and their job is to connect this whole system to the outside world. They plug into your company's security tools and provide a single, unified dashboard for everyone, from developers to operators, which makes this incredibly complex system actually manageable.
All right, let's take a step back and see how all these pieces, the global network, that modern front door, and the central blueprints, all come together to handle just one single user request from start to finish.
And there it is, the complete journey. A user's request gets sent to the nearest, fastest cluster by a global load balancer. It enters through the modern Gateway API, it gets a full security check from an API gateway, and the entire process is overseen by that central management platform, making sure every single step follows the rules. This, right here, is the unseen engine of a global app.
You know, building a system like this isn't just about the technology. It's a strategic decision. It's about taming complexity so you can prepare for the future. So the final question to think about is, as your own systems grow and get more complex, do you have a clear blueprint to guide you?